2 to the x. And I brought my calculator because I wanted to go through some of this stuff quickly. Alright, we're headed toward a graph, and we're going to do a table to help us plot some points. Alright, so I'm going to turn my on, we don't need that anymore, and I'm just going to go through and I'm going to start raising 2 to powers. So, for example, when x is 0, what's my y value? What's going to be whatever 2 to the 0th power is. And you know what, I probably could have come up with that on my own, because our rule is anything to the 0th power is what? Yeah. The 5 of us that agree on that, yes. Okay, if you did not know this, this is going to be a critical exponential rule, a critical exponent rule. You take anything and you raise it to the 0th power, except for 0, you're going to get 0. What's 3 to the 0th power? 1. I'm sorry, I was saying 0, wasn't I? Dang it! It's so important I have to mess it up. Okay, no. Anything to the 0th power except for 0 gets me 1. So 3 to the 0th power is 1. 0.5 to the 0th power gets me 1. 1,000 to the 0th power gets me 1. 1,001 or 10,001 to the 0th power gets me 1. Any number except 0 raised to the 0th power gets me 1. Okay? Deal? It may not make sense, but it is what it is. What's 0 to the 0th?
-1.
The answer is you don't know. The answer is no. Yeah, it's not defined. And there's a reason why, but we won't get to that. I encourage you to think about that though. Okay, so for any other number except 0 raised to the 0th power, you get 1. Alright, what if I take 1 and plug that in for my exponent? What's 2 to the 1st power? I'm not going to use the calculator. 2 to the 1st is 2. Thank you for not making me use my calculator. Alright, what if I take 2 and I plug it in as my exponent? What's 2 squared? Okay, what if I go up by 1 more and I do 2 to the 3rd power?
8.
I get up to 8. Good. How far can we go?
16.
Do you guys notice a pattern? We could actually probably go on for a while. Because every time my exponent goes up by 1, what's happening to my y value? I'm doubling it, right? Times 2, times 2, times 2, times 2. So if I went to the 5th power, this would be 32, 64, 128, 256. Okay? This even works for like off the wall numbers. Like what if I did 1.383? What if I took 2 and raised it to that power? 2 to the 1.383 power is, let's call that 2.6081. Okay? What if I add 1 to that exponent? What if I did 2 to the 2.383 power? I get 5.2162. Is this number twice as big as that number? Multiply this by 2, don't you get this? Or if I divide this one by 2, I get the other one, right? Same exact number. Why? Why is it I'm doubling that number every time I add 1 to the exponent? Hmm?
You're like squaring it?
No, not exactly.
That's our basis too.
Because my base is 2. Every time I add 1 to that exponent, I'm multiplying by another 2, and then another 2, and then another 2, and so on, right? So yeah, I'm getting numbers like this. Now what if x is negative? What if I did 2 to the negative 1? I get 0.5. Let's make that a fraction. Math frac. I do that. I don't know why I just did that. What if I raise it to the negative 2 power? What's 2 to the negative 2? 0.25. And 0.25 as a fraction is 1/4. What if I went to the negative 3 power?
1/8.
Yeah, I get 1/8, which comes out to be 0.125. What about the negative 4 power? 1/16, which is 0.0625. Is there another pattern here? When I subtract one from my exponent, when I go more and more negative, what's happening to my y values? They're getting smaller, right? How smaller? By half each time, right? Why are they going by half? Because when I subtract one from the exponent, I'm dividing a 2 away from that, right? I'm dividing by 2, dividing by 2, dividing by 2. And notice, decimal y's. What's happening with these y values? They're getting smaller by half, right? How long till I get to 0? How many times do I have to take a number and divide it by 2 before I get to 0?
Forever?
Yeah, more than forever, right? And the simple idea is this is a positive number, and if I take a positive number and I divide it by positive 2, aren't I going to get a positive number? Isn't a positive divided by positive always going to be positive? And if it's always positive, then it's never 0, right? If it never gets to 0, then certainly does it ever go negative. No, right? I mean, so if we start plotting these points, we have 0, 1. We had 1, 2, 2, 4. We have 3, 1, 2, 3, 8. And you know what? I mean, I could do 416, 532, but I mean, those are going to start to get to be pretty big numbers, right? So I'll leave it here. Well, you know what? We can do these bottom two. 1.383 is, I don't know, not quite 1.5. And that's at like 2.6-ish. So 2 point, does that look good enough for y'all? Just draw a really big dot, right? It's in that neighborhood. And 2.4-ish is at 5.2-ish. Like that somewhere? Okay. If we go negative, negative 1, 2. At negative 1, we're at 1/2. We're halfway in between 1 and the x-axis, right? Then if we go to negative 2, we're halfway in between there and there. At negative 3, we're halfway. Negative 4, we're halfway. Negative 5, we're halfway. See what's happening? As my curve goes left, I get these values that start getting really, really, really close to the x-axis. We might even say arbitrarily close to the x-axis, but they never quite get there. So when we have a situation like that, we call that an asymptote.